Ay, kumusta? Ako nga pala si Jeffrey. At ngayon, ating pag-uusapan ang patungkol sa fictional force. Pero, bago tayo magsimula, alam niyo ba na we are executing fictional force in our day-to-day lives? Kaya dalaw ng pagkilos ko dito kanina sa sofa, pag kuha na itong band, or is the month sa daliring sa kamay, nandakad, sulat and everything. We're executing fictional force. Pero ano nga ba talaga ang fictional force? So ano? Wala na ba kayo matuta? So pag sinabi natin frictional force, sorry may dalawang box ngayon. Alis kasi kami ngayon, ako lang titira sa bahay. Ito naman no. Pero, dito naman sila Emery sa Juliana para sikasuin at explain sa inyo kung anong frictional force kaya. Emery, Juliana, hindi ba tulungan dito?
Sure thing, my The frictional force is a force that creates resistance to the motion of the surface of one object had to contact with another surface of an object. In simple words, frictional force refers to two object surfaces that had contact and slid against each other. But wait, do you know that frictional force have different types? Frictions on solid surfaces are classified as static, kinetic, rolling, and sliding friction. Meanwhile, frictions in fluids and gases are classified as fluid friction. Static friction is a friction force with balances applied force on the duration of the object. In short, static friction is where the object is at rest. An example of static friction is a car parked in a garage and a book on a tabletop. Kinetic friction can easily be described as a force that holds back a sliding object. Its force acts if the object slides in the opposite direction to the way it wants to slide. An example of kinetic friction is rubbing your hands. Wrapping your hands in different directions creates friction and results in heat on the palm.
Moreover, rolling friction is where the object is being used with wheels or the rolling of balls. An example of rolling friction is a ball rolled on the ground. Sliding friction is also known as kinetic friction. It is a type of friction where it is needed to keep a surface sliding along another surface of an object. An example of sliding friction is a child sliding down a slide at children's park.
The next thing we are going to learn is the formula of frictional friction. Fortunately, the formula of friction is much more easier to understand and to be derived. However, that would be only applicable if you would understand the formula more clearly. You see, there are two ways where friction might be applied, on a horizontal plane and a vertical plane. If our problem indicates a horizontal plane situation, then we would follow the normal friction formula, which would be derived as friction force is equal to coefficient of friction multiplied by the normal force. However, if our situation resembles a vertical plane, it would be represented in a different formula. Now, we wouldn't be advancing it too much as there is really much need to take consideration. So for now, we're just going to right into the problem itself, which will be further analyzed by David Timao and Henry Dantes.
First and foremost, in solving a problem, it is necessary to understand the problem we are facing. For our today's example, we will be focusing entirely on frictional force. But nevertheless, I wouldn't waste any more time talking here, so let's just get straight into it. A girl is pressing a 2 kilogram book against a vertical wall. If the coefficient of friction between the book and the wall is 0.30, how hard should a girl push to allow the book to slide down the wall at a constant speed? The first step that is needed to conduct is to draw the free body diagram and identify the force that is acting on an object. In this case, it was a book. There are four forces acting on the book. There are downward gravitational force, the applied force, or the force from the push, a frictional force that is parallel to the wall, and a normal force from the wall.
Following the Grassi method, one must always identify the given first. There are three given in the problem. A mass that is equal to 2 kg, a coefficient of friction which is 0.30, and a gravity of 9.8 meter per second squared, which is constant. The letter R in Greta stands for required. In this case, the friction force is the force that is being looked for, because it is dependent to the girl's exertion in order for the book to slide down the wall in a constant speed. Hence, the required will be friction force. In order to find the friction force, we must apply the formula of friction force, which is Ff is equals to mu Fn for our equation. Then, we'll proceed to the solution. Given that our normal force is still unknown, solving for it is the first thing to do. Accordingly, the formula for normal force is mass multiplied by gravity. And since the elements in this formula has already been settled, solving for the friction force will now be effortless. To begin, substitute the given, which will lead to 0.30 coefficient of friction multiplied by 19.6 Newton normal force. Second, compute and perform the necessary operations. In this case, multiply the coefficient of friction, which is 0.30, and the normal force of 19.6 newtons to come up with a final answer of. Lastly, we conclude that the girl needs 5.88 Newton force in order for the book to slide down the wall at a constant speed.
Whew. There you have it. Thank you for sticking around and listening to our lesson. Kaya ngayon na nakabalik. Hello. Pero yan, I hope you learned much more about frictional forces, and I wish you all the best of your educational journey. Ikaw lang sinabi ko, pero have fun. Okay, mag-stem.